Intro to AWS D1.1 Structural Steel Welding Code. Clause 4, Qualification, Part 2. My name is Gary A. Pace. I'm a PE and CWI, April 2019. Okay, we're going to keep grinding our way through Clause 4, Qualification. There's no way to do the qualification clause, and cover the material in any kind of depth and do it in one episode unless I just did one massive episode. So I'm kind of breaking it down into bite-sized chunks. So clause 4 is qualification, and this is the second part of it. We're going to keep slogging through qualification of, we're going to cover WPS as this go around and some of the testing and whatnot required and how to read some of the tables that are included in clause 4 for weld procedure qualification. The PQR combines all the information of the WPS and adds the test results to provide a complete document that certifies the welding specification. Tells everybody what we did, how we did it, when we did it, the date, time, everything. This document is also required by all codes unless you are qualifying under the American Welding Society specifications. Under certain conditions, the WPS may be considered pre-qualified, in which the PQR is not required. So that's where we're headed in this episode. In the next episode, we'll talk about needing a PQR. But we're talking about pre-qualification. Here we have a WPS welding procedure specification. This is an ASME Section 9 American Society of Mechanical Engineers, but an AWS one looks pretty damn similar. You're going to list filler metals and techniques and address all the essential and non-essential variables on here, preheats, positions, whatever information is required by that code. If you like this format, you can use it. If you don't like this format, you can invent your own. Most codes have a suggested format, but if you've got one that you like, run with it. I worked for a company years ago, and theirs was all written out. We did ASME work, American Society of Mechanical Engineers, a lot of ASME work, so we just had everything typed out and addressed in paragraph form. Didn't look anything like this. It looked like a book report or something. But it worked. Our clients liked it. Everything was addressed. We had a couple little sketches on there, maybe a table or two, but that's what it looked like. This is what a welding procedure specification looks like. Even though we're not going to be talking really about procedure qualification records in clause 3, you need to know what we're talking about so that you know what we're not talking about when we're not talking about it. So this is a procedure qualification record. There's information there for bend tests, tensile tests, and then you put down all the information over on the left-hand side, voltages, amperages, filler metals used, base metals, a sketch of the joint, whatever pertinent information you're going to need. And then you're going to take this, type it up, add your tensile test, your bend test, your toughness test, whatever is prescribed by that particular code, and then you're going to bundle that all up, give it a number, a PQR number, and that's what you're going to have. That'll be your procedure qualification record that will support your welding procedure specification. PQR content, what goes on a PQR? Generally, any supporting documentation, material specifications, electrode specifications, shielding gas specifications, all required testing, non-destructive and destructive. These tests typically include X-ray examinations, ultrasonic, tensile testing, bend testing, and when required, impact testing. All this stuff gets bundled up into a PQR. Like anything we do with any of these codes, you need to realize there's a wall between welding procedure, specification, qualification, WPSs, and PQRs. They're on one side of the wall. And on the other side of the wall, we've got performance qualification, which is qualifying the welder. So right now we're going into part B, which is
Welding Procedure Specification Qualification, WPSs. We are not talking about qualification of people. We'll do that in the next edition of this podcast, YouTube video series, whatever we got going on here. So we need to respect the wall. A lot of times, like I've said, a guy will be digging through Part C and say, oh my God, I got to do this for my WPSs. You got to respect the wall. You got to realize if you're dealing with the welding procedures, that's in one area of the code. That's in Part B. Part C is performance. So just need to keep this in mind. One of the basic ideas, one of the basic tenets of these welding codes is we don't get on the other side of the wall. We stay in our swim lanes. If we're doing procedures, we do procedures. We don't dabble and read something out of the performance side or vice versa. Part B, Welding Procedure Specification, WPS Qualification. 4.4, Production Weld Positions Qualified. The production weld positions qualified by plate test shall conform to the requirements of Clause 4 and Table 4.1. In the production welding positions qualified by tubular tests shall conform to the requirements of Clause 9 and Table 9.9. Table 4.1. So Table 4.1 is WPS qualification, production welding positions qualified by plate, pipe, or box tube tests. So right here, I'm just going to look at the plate one, and then you guys can figure out the rest. So I would start with my weld type. So I've got the little purple box around complete joint penetration groove weld. Then I'm going to pick my position that I'm going to qualify it in. So I've got 3G, which is vertical. So if I qualify my test in a complete joint penetration groove with 3G, I'm allowed to run complete joint penetration grooves in vertical, partial joint penetration grooves in vertical, and fillets in vertical. This is for production, for plate welding qualified. For production pipe, I would be allowed to go in, for butt joints, complete joint penetration, I'd be allowed to go vertical and vertical. So that's how it works. You just kind of got to look on here and see what else it qualifies. Flat just qualifies flat. 2G qualifies flat and horizontal. The 4G overhead qualifies overhead. Don't confuse this qualification with the personnel qualification table. Two separate tables. There's a WPS qualification, positions qualified, and then there's a people one, a personnel performance qualification. So be careful with those and don't get those two mixed up. I speak from experience, having looked at one and then come to my senses and, I'm looking at the wrong damn table. So that's what this is telling us. It's telling us that if whatever situation or test position we want to qualify our test plate in, it also tells what else we're qualified to run in. 4.5, types of qualification tests. The type and number of qualification tests required to qualify a WPS for a given thickness, diameter, or both shall conform to Table 4.2, complete joint penetration, Table 4.3, partial joint penetration, or Table 4.4, fillet. Details on the individual NDT and mechanical test requirements are found in the following subclauses. So it's going to tell us to chase, if we're doing, complete joint penetration, we got to go to Table 4.2. But each one of these subclauses is going to tell us, okay, 4.91 is going to tell us how to do visual inspection. 4.92 is going to tell us what we need for NDT. 4.931 is going to tell us face, root, and side bend tests required. 4 is going to tell us the reduced section tension tests are required. 5 is going to tell us all weld metal tension tests are required. And 6 is going to tell us which macroetch is required. So you just got to do a little digging and reading to see what is required for your particular joint configuration. Because the testing that's required for a fillet weld is not going to be the same that's required for a partial joint penetration weld or a complete joint penetration weld. So you just got to do some digging and reading and develop some familiarity with these tables and these sub-clauses if you're going to qualify weld procedures. Table 4.2 tells us, okay, so for WPS qualification, complete joint penetration groove welds, the number and type of test specimens and range thickness and diameters qualified. So we're going to start with that blue square I've got under nominal plate thickness. Let's say our test plate is let's say it's 1.25 inches. So we go to there, our test plate's 1.25 inches. It's going to tell us the red square or rectangle of over number of specimens is going to tell us, okay, we got to do 2 reduced section tension tests. So we've got that right there. That's kind of a cheesy picture, but I pulled it out of a military manual. So we got to do 2 tensils, and then we don't have to do any root bends or face bends because the material's too thick. So we're going to do side bends. So we got to do 4 side bends. And there's a picture with our 4 side bend test bent there. And then over under the purple, it tells us the nominal plate or pipe or tube thickness that we're qualified. So we can weld everything between 1/8 of an inch and unlimited. So that's how you read that table. And if we were going to do electro slag or electro gas welding, that is right underneath it. I've never done that, so I'm not going to venture down that road, but it looks like that table functions pretty much the same. 4.6, weld types for WPS qualification. For the purpose of WPS qualification, weld types shall be classified as follows: complete joint penetration groove welds for non-tubular connections, partial joint penetration groove welds for non-tubular connections, fillet welds, complete joint penetration groove welds for tubular connections, partial penetration groove welds for tubular T, Y, and K connections and butt joints, and then plug and slot welds. Generally, I've just dealt with complete joint penetration groove welds for ASME or AWS D1.1. But here's the 6 types. I'm not going to show a picture for all 6, but for a complete joint penetration groove weld, that's pretty self-explanatory. Partial penetration groove welds for non-tubular connections. I'll show those 2 on another slide. Here's what we're talking about when we're talking about complete joint penetration and partial joint penetration groove welds. A complete joint penetration groove weld is a weld in which the weld goes through the thickness of the base material. A partial joint penetration weld only goes some percentage or some fraction of the way, some portion of the distance into the base material. There is no complete weld thickness. You know, there's no 100% weld that is equivalent to the base metal thickness. I don't know if I explained that very well, but there's the pictures. You guys can get an idea of the difference between complete joint penetration and partial joint penetration groove welds for non-tubular situations. Preparation of a WPS. The manufacturer or contractor shall prepare a written WPS that specifies all the applicable essential variables referenced in 4.8. The specific values for these WPS variables shall be obtained from the procedure qualification record, the PQR, which shall serve as the written confirmation of a successful WPS qualification. So like I've said before, I've said it a couple of different places in different YouTube videos that, the PQR is our test. So we run our tests, we do our test samples, we do some bends, we do some tensile pulls or whatever the code requires for that specific joint configuration. And then we take that information, we put it on a PQR, and then the PQR supports our WPS. And that's the basis of most of these codes, is you've got a WPS that is supported by a PQR where you did some testing that says, yep, this is how we're going to do it, and the WPS is the recipe. 4.8.3 Base Metal Qualification. WPSs requiring qualification that use base metals listed in Table 3.1 shall qualify other base metal groups in conformance with Table 4.8. WPSs for base metals not listed in 3.1 or Table 4.9 shall be qualified in conformance with Clause 4. The use of unlisted base metals shall be approved by the engineer. WPSs with steels listed in 4.9 shall also qualify in Table 3.1, qualify Table 3.1 or Table 4.9. Steels in conformance with Table 4.8. Table 4.9 also contains recommendations for matching strength filler material and minimum preheat and interpass temperatures for the materials in the table. Table 4.9 gives us code-approved base metals and filler metals requiring qualification. So on Table 3.1, that's all the materials that you can use without qualification if you follow the rules. It's pre-qualified, you can go with it. But here you can see like the top one in that red box that I've highlighted is ASTM A514, quenched and tempered material. And you can see that over here in the other red box underneath electrode classification is the tensile strengths on this. It's E115 or E118. This stuff should, anytime you see anything above a 70, it should tell you that you need to, tread lightly. So this material has a high tensile strength, which means it's kind of onerous to weld. It can be welded, but you just can't go at it in a haphazard manner. So, but basically this table just tells you these are the materials, these are the filler metals you got to use to weld these materials, and here's the preheats. And you got to qualify these, if you're going to use these materials, you got to qualify a WPS and have supporting PQRs and test data supporting your WPS. Table 4.8 tells us what base metals we get if we qualify a procedure with a certain material. So if we qualify, for this example, if we qualify, if our up there in the blue in the left hand, I've got PQR base metal. So let's say I use PQR base metal is going to be ASTM A913 grade 50, which is a group 2 steel from table 3.1. So I qualify with that. I can weld any group 1 steel to any group 1 steel. I can weld any group 2 steel to any group 1 steel. And I can weld any group 2 steel to any group 2 steel. So if you know what you're doing and kind of know how to manipulate this table or the nuances of it, if I was going to weld a lot of group 1 steels, I wouldn't even, if I was going to weld group 1 and group 2 steels, I would not even probably qualify a group 1 steel. I would just go and qualify my group 2 steel to a group 2 steel, and then I've got group 1 to group 1, group 2 to group 1, and group 2 to group 2. So that's some of the nuances that you need to learn as you dig around in this code. But this would be a situation where I get ASTM 913, I would get one material, which is a group 2 steel, and then I'd get everything that is group 2 or group 1, and I can weld those together using my PQR that I've put together, as long as I write a WPS. And then down at the bottom, you have unlisted steels. This is where they really tighten up. If the engineer even lets you use an unlisted steel, you can only use, they're a lot tighter on that end of the scale. So, just something you need to be cognizant of as you're reading through this. So, 4.8.4 Preheat and Interpass temperature. The minimum preheat and interpass temperature should be established on the basis of steel composition as shown in Table 3.1. Alternatively, recognized methods of prediction or guidelines such as those provided in Annex H or other methods may be used. Preheat and interpass temperatures lower than required per Table 3.3 or calculated per Annex H may be used provided they are approved by the engineer and qualified by WPS testing. So this lays out how you need to address preheat. You go to Table 3.1 and it's going to tell you what your preheats need to be, and then there's some guidelines in Annex H. And then there's other methods you can use to calculate it. If your preheat temperature is lower than required on Table 3.3 or calculated in Annex H, you need to prove to the engineer by qualification that, hey, we've done this. We can weld this metal with this preheat, and the engineer's got to approve it. If the engineer doesn't like what you're doing, you got to do what the engineer says you need to do. As I've said all along, a lot of what goes on in AWS D1.1 is controlled by the engineer. If the engineer says, "Yep, we're going to do it this way," then there's not a lot anybody can say about it. I mean, I guess you could, but there's not really. The engineer, he's the one that's going to hang if something goes wrong, because he's the guy making the decisions. The welded test assemblies conforming to 4.9.2 shall have test specimens prepared by cutting the test plate as shown in figures 4.5 through 4.7, whichever is applicable. The test specimens shall be prepared for testing in conformance with figures 4.8, 4.9, 4.10, and 4.14 as applicable. Visual inspection of welds. The visual inspection or acceptance criteria for the qualification of groove and fillet welds, excluding weld tabs, shall conform to the following requirements as applicable. So for groove welds, they'll meet the following requirements. Any crack shall be unacceptable regardless of size. Welding cracks are not good. Any crack is, you got to repair it. All craters need to be filled to the full cross section of the weld. Weld reinforcement shall not exceed 1/8 of an inch. The weld profile shall conform to figure 5.4 and shall have complete fusion. Can't have any undercut to exceed 1/32 of an inch. From what I was told, that's about your fingernail. If you can catch your fingernail on it, it's too much undercut. Weld root for complete joint penetration groove shall be inspected and shall not have any cracks, incomplete fusion, or inadequate joint penetration. So this is what lays out your visual inspection for welds. For groove welds, 4.9.1.1 is groove weld inspection criteria. 4.9.1 Visual inspection of welds. 4.9.1.2 Visual inspection of fillet welds. Fillet welds shall meet the following requirements. Any crack shall be unacceptable, regardless of size. All craters shall be filled to the full cross-section of the weld. The fillet weld leg sizes shall not be less than the required leg sizes. Fillet weld profile shall meet the requirements of figure 5.4. Base metal undercut shall not exceed 1/32 of an inch. So our visual weld inspection for groove welds and fillet welds, there's a lot of commonality here. Cracks are unacceptable. Just little cracks, big cracks, they're all unacceptable. You got to fill in the craters. The profile needs to meet the requirements of figure 5.4, which, you got to follow those directions. And the base metal undercut shall not exceed 1/32 of an inch. And I guess I was told and I guess taught that a 32nd of an inch is if you can catch your fingernail on it, it's too much undercut. If you can't catch your fingernail on it, then it's good to go. That's a 32nd, is the measurement that I was taught. 4.9.2 NDT. Before preparing mechanical test specimens, the qualification test plate, pipe, or tubing shall be non-destructively tested for soundness as follows. So you can use RT or UT. Either RT or UT shall be used. The entire length of the weld in test plates, except for the discard lengths at each end, shall be examined in conformance with Clause 6, Part E or F, and Clause 9, Part F for tubulars. For acceptable qualification, the weld as revealed by RT or UT shall conform to the requirements of Clause 6, Part C, or Clause 9 or Part F for tubulars. So what it's telling you is before you start slicing up your test plate to do mechanical testing, your bends and tensils, you need to either shoot an x-ray through it or you need to do ultrasonic testing for it. And this gives you the area where you need to look in the code for the acceptance criteria. So this is a little different than ASME Section 9, which doesn't just right off the bat ask you to do NDE. This one asks you to do NDE, ASME Section 9. Depending on what you're doing, you can just do a couple of bends and a couple of tensile tests, and you're good to go. Each specimen shall be bent in a bend test jig that meets the requirements shown in figure 411 or 413 or is substantially in conformance with those figures, provided the maximum bend radius is not exceeded. Any convenient means may be used to move the plunger member with relation to the die member. So I took this one out of ASME Section 9, and I'm pretty sure they're pretty close to being the same. I don't know what the nuances are, if there's any difference between the two, but you notice where it says or is substantially in conformance with those figures. So I think that means that if you're pretty close, you can use the same type of bend test jig. But this is what they look like, and it's all mapped out if you want to build your own. So when material combinations differ markedly in mechanical bending properties, as between two base materials or between the weld metal and the base metal, longitudinal bend tests, face and root, may be used in lieu of the transverse face and root bend tests. The weld metal test assemblies conforming to 4.9.2 shall have test specimens prepared by cutting the test plate as shown in figure 4.6 or 4.7, whichever is applicable. The test specimens for the longitudinal bend tests shall be prepared for testing as shown in figure 4.9.33 Acceptance criteria for bend tests. The contact surface of the bend test specimen shall be visually examined for surface discontinuities. For acceptance, the surface shall contain no discontinuities exceeding the following dimensions. So you can't have anything, number one, 1/8 of an inch measured in any direction on the surface. 3/8 inch is the sum of the greatest dimensions of all discontinuities exceeding 1/32 of an inch, but less than or equal to 1/8 of an inch. 1/4 inch is the maximum corner crack, except when the corner crack results from visible slag inclusions or other fusion type discontinuities. Then 1/8 of an inch maximum shall apply. So, and then if you've got specimens with corner cracks, exceeding this with no evidence of slag inclusions, you can disregard them. Maybe you didn't grind a good enough radius on it or whatever. So this is where you find your acceptance criteria for bend tests. And it's pretty self-explanatory. You just have to read through it, do your bend tests, look at it, and just go down through it 1, 2, 3, and see what happens, and make your judgment on this criteria right here. Here's some transverse bend specimens and longitudinal bend test specimens. You can see, it gives you an idea of the difference in the two different types of bend tests. So, we've got sides and bends and face and roots, and just opposed to a face and a root. So just some compare and contrast between transverse bend tests and longitudinal bend test specimens. Macroetch test. The weld test specimen shall be prepared with a finish suitable for macroetch examination. A suitable solution shall be used for etching to give a clear definition of the weld. So this is a example of a macroetch that I pulled up. You can see that they've taken a slice through the weld. It's not a fillet weld per se, but it gives you an idea of what's going on. Then you spray a solution on there. Sometimes it's a acidic solution. You spray it on there. The acid's usually cut with a alcohol or something like that, and you leave it on there for an amount of time. Well, usually you polish it. You hit it with some fine sandpaper, a sanding disc or something to get it polished. And then you hit it with an acid that's been cut with an alcohol. You can find some examples on the internet of how to do this. And then it'll bring out the weld and show you where the weld is in the heat affected zone and give you an idea of what happened in the weld. And then you go from there. You clean it off and maybe put some hairspray on it to preserve it, and then you make your decision on the criteria of the welding code. Did this weld? Did we do it right? Did we get enough penetration? Do we like what we're seeing? Whatever. You make a judgment call from there on the criteria and the code requirements. If any one specimen of all those tested fails to meet the test requirements, 2 retests for that particular type of test specimen may be performed with specimens cut from the same WPS qualification material. The results of both test specimens shall meet the test requirements. For materials over 1.5 inch thick, failure of a specimen shall require testing of all specimens of the same type from 2 additional locations in the test material. So if you run a test and you have one bend test go bad on you and the material's less than 1.5 inches thick, you can cut 2 more bend tests, and if those pass and you document it, you're good to go. Or you have one tensile test that doesn't go your way. So there's some ways around this. So sometimes when you're doing a WPS, you're doing a test sample, you don't want to minimize the amount of material you've got to work with, because if something goes wrong, you got to start all over if you don't have enough material to cut another tensile or another bend test sample. So generally I'll look at the minimum I need, and then I'll throw in a little extra material just in case. Or sometimes you can save that material. You'll get that material back from the lab, and let's say somebody comes up later and wants to do some impact testing. You've got your test material right there, and you can cut out and do some bend testing. So bottom line for me is, if you're going to do a WPS, if you're going to do a test plate, don't just use the minimum amount that's required. If it's a few dollars more, get some extra plate, weld it out so you got some extra material. Maybe you need to send something to get heat treated, who knows. But just from past experience, a lot of times I've found it easier long run to just, little extra money, but it'll save you in the back end when you need something else done. You don't have to run a brand new test. 4.10, complete joint penetration groove welds. See Table 4.2 for the requirements for qualifying a WPS of a CJP weld on non-tubular connections. Figures 4.5 and 4.7 for appropriate test plates. 410.11 corner or T-joint test specimens for groove welds and corner or T-joints shall be butt joints having the same groove configuration as the corner or a T-joint to be used in construction, except the depth of the groove need not exceed 1 inch. Welding processes requiring qualification. Gas tungsten arc welding, gas metal arc welding, short circuiting, electro slag welding, and electro gas welding may be used provided the WPSs are qualified in conformance with the requirements of Clause 4. WPS requirements for gas metal arc welding, short circuiting. Prior to the use, the contractor shall prepare a WPS and qualify each WPS in accordance with requirements of Clause 4. The essential variable limitations in Table 4.5 for GMAW shall also apply for GMAWS. So that's just telling you, that these, we've mentioned it before, these 4 processes, you can use them. There's no pre-qualification with these material or these welding processes. You have to qualify. If you're going to use these processes, everything has to be qualified. That second paragraph, that's telling us that when we're using GMAW short circuiting, we have to follow the same essential variables as we do with GMAW if it's flux or globular or spray arc. So the same essential variables apply to both transfer modes, short circuiting and spray. Any questions in regards to this YouTube video? We covered Clause 4. We talked about bend tests, tensile tests, how to read some of the tables, some of the nuances involved in qualifying a weld procedure to AWS D1.1. We covered welding positions and how they play into the tables, some of the materials you can use. So if you have any questions, you know how to contact me. Either email me or send me a message leave a message or whatever on the YouTube. My name's Gary A. Pace. I'm a PE, CWI, Katy, Texas. There's my website. Take care. Thanks. GP out.